Assalamu alaikum, my dear students. Hope you are doing well by the grace of Almighty. Welcome to our NIEVS Home School. This is Marjia Islam, Assistant Teacher of Science, National Ideal English Version School, morning shift. Now I am going to take a physics class for class 9, our lecture number 9 and our today's topic chapter 2 discussion. Now start our class. This is our new chapter, our chapter 2. Chapter name is motion. Main topic of this chapter here. The main topic number 1, rest and motion. Number 2, different types of motion. This is motion. This motion is number 1, linear motion, circular motion, translational motion and periodic motion. Number 3, scalar and vector quantities. Number 4, distance and displacement. Number 5, speed and velocity. Number 6, acceleration and retardation. Number 7, equations of motion. This is the motion of equations. Number 1 equation, v equal to u plus at. Here v is the final velocity and u is the initial velocity and a is the acceleration and t is the time. Number 2, s equal to u plus v by 2 into t. Number 3, s equal to ut plus half at square. Number 4, v square equal to u square plus 2as. And number 8, here is the topic laws of falling bodies. Now we can start this chapter. Our first topic is rest and motion. Here this is our first topic. First topic name is rest and motion. This is the first topic, rest and motion. Now we can define when an object does not change its position with respect to time. I repeat, when an object does not change its position with respect to time, then it is at rest. And when an object changes its position with time, then it is in motion. To specify the motion of any object, it has to be mentioned with respect to a reference point. This reference point is not an absolute one. We can conveniently choose any point as a reference point or origin. Now we consider a man outside of the train standing on the station. Will say you and your friend are both in motion. Nobody is at rest. Then whose statement is true? Your statement or of the man standing in the station. In fact, both are correct. The reason is, if the reference point or the origin moves at a uniform velocity, then we cannot tell firmly whether the reference point is moving at a uniform velocity, or accurately it is at rest and all other things are moving at uniform velocity in the opposite direction. I repeat, in the opposite direction. Therefore, we can say if an object changes its position with respect to an origin, then the object is in motion with respect to that origin. It is not our headache whether the origin is at rest or moving at uniform velocity. This is not important since every motion is relative. Now, not only this, if we want to search out an absolute rest reference point, we will be in trouble. If we consider anything on the surface of the earth as origin, one can object as earth is not stationary, rather it is rotating about its own axis, so everything on its surface is also rotating. Alternatively, we can say the center of the earth is the origin. Someone else can come up with the objection that the center of the earth is not stationary, it revolves around the sun. Then we can say more intelligently, the center of the sun must be the origin. Then another person can confidently say that the sun is also not stationary, it is also revolving around the center of our galaxy. Surely you are feeling that no one can dare to say the center of our galaxy is the origin. Now who can say that the galaxy and the universe are stationary? Not only this, if the center of the galaxy is considered as the origin to describe any position on the surface, do you realize the extent of complexities that may arise? In fact, we don't need such type of complexities. For our purpose, we can consider any point as the origin which seems stationary to us. In this case, we have to mention all the measurements are done with respect to this origin. In this way, scientists have done all the measurements starting from the nucleus of an atom to the satellites launched in space with no problems whatsoever. Now we go to the point different type of motions. We see various type of motions around us: vibrations, rotations and separations. All these are examples of different kind of motions. Probable motion are unlimited, but if we wish, we can talk about some important types of motion separately. Now our number point 1, linear motion. It is an example of easiest type of motion. I repeat, it is an example of the easiest type of motion. If anything moves along a straight line, then its motion is called linear motion. I repeat, if anything moves along a straight line, then its motion is called linear motion. If an object is pushed off on a plane surface, then it moves along a straight line. If a ball is allowed to fall from a height, it will fall straight downwards, so it is also a linear motion. This is the example of linear motion. If a ball is allowed to fall from a height, it will fall straight downwards, so it is also a linear motion. Now go to the next motion. Our motion name is circular motion. When a body rotates about a particular point or a line, keeping the distance of the particles of the body unchanged, it is called circular motion. Though the motion of electric fans, the hands of clock, etc. are example of circular motion. A wonderful example of circular motion is the moon in the sky. The moon is not tied to the earth, although it is revolving around the earth. Neither it is falling on to the earth's surface. Now go to the next motion, translational motion. If an object moves in such a way that all the particles of the object travel the same distance at the same time in the same direction, then its motion is called translational motion. I repeat, the translational motion. What is translational motion? Translational motion, if an object moves in such a way that all the particles of the object travel with, I repeat, travel with same distance at the same time in the same direction, then its motion is called translational motion. When something moves in a straight path, then its example is very common. If we do not consider the circular motion of the wheel of a car, then straight advancement of the car is an example of translational motion. At this time, every point of the car will travel the same distance in equal time in the same direction. Now look at the picture. This is the picture of non-translational motion and this is the picture of translational motion, because this picture here is not the same direction, but here the direction is same. There is no obligation that the translational motion will be straight. Now go to the next topic, periodic motion. If the motion of a moving object passes repeatedly through a definite point in the same direction in the same manner in a definite interval of time, then this motion is called periodic motion. I repeat, periodic motion. If the motion of a moving object passes repeatedly through a definite point in the same direction in the same manner in a definite interval of time, then this motion is called periodic motion. The vibrational motion of our heart is periodic. Now go to the next topic, our simple harmonic motion. Simple harmonic motion is a special type of periodic motion. In case of oscillatory motion, the object oscillates on both sides of a definite points. Now, starting from its complete rest position, the object starts moving slowly. When the object comes to the center, it has the maximum velocity, then its velocity starts to decrease until it comes to rest. Then it changes its path of motion and moves in the opposite direction. In the opposite direction, then maximum velocity is attained, then its velocity decreases again. It stops its motion completely and starts to repeat its motion slowly again in the previous direction. It continues its motion in this fashion. There are so many examples of oscillatory motion around us. The motion of an object hanging from a spring is an example of oscillatory motion. The oscillatory baby on a swing or the pendulum of a clock are the example of oscillatory motion. Look at the picture. This is the example of simple harmonic motion. When we speak, the air molecules carry the sound forward by this type motion. Now we go to the topic, our scalar and vector quantities. Scalar and vector quantities. We know anything that can be measured is called quantity. I repeat, we know anything that can be measured is called a quantity. Joy and sorrow are not quantities, but temperature is a quantity. My dear students, look at the picture here. Vector A and vector B. Look at the picture here. This is a vector A, this is a vector B, and this is a vector C, and this is a vector D. Now look, vector A and vector B are equal in all respect, although in different position. But vector C, this is vector C, this is vector C, is different from A and B because its direction is different. But magnitude is same. C is different from A and B because their magnitude is same, but direction is different. Here A and B's direction is this, but C's direction is this. That's why this A, B and C's direction are different, but A and B's direction is same, but C is different from A and B. Now vector D is different. D is the vector. D is different from C because direction is same but their magnitude is not same. Here look at the picture, C and D. These two vectors direction is same because this direction is this, but here this C vector is long but D vector is short than C. So we can tell this magnitude is not same. Now the quantity which can be expressed only by a single number is called a scalar quantity. On the other hand, the quantities for which direction has to be mentioned in addition to its magnitude are called vector quantities. I repeat, what is scalar quantities and what is vector quantities. The quantity which can be expressed only by a single number is called a scalar quantity. On the other hand, the quantities for which direction has to be mentioned in addition to its magnitude are called vector quantities. Temperature examples of scalar are time, length and masses, and examples of vectors are velocity and force. Now to differentiate vector quantities from scalar quantities, they are written in bold font like this. This is the bold form, this is a small letter bold form, and this is capital letter bold form. In book or in computer printing, it is easy to write anything in bold form, but when anyone writes on a paper, then to express anything as a vector, a small arrow is used over it like this. A small arrow over the letter this small arrow is used over it when to express anything as a vector. Now Go to the next topic, distance and displacement. Distance and displacement, this is also important. We are quite familiar with the word distance, but we do not use the word displacement in our daily life. We want to understand the relation between the two words distance and displacement with the help of an example. A curved path is shown figure. This is the figure, curved path figure. The distance traveled with respect to the point A is denoted by the number 1, 2, 3 in kilometer. Here A is the point and B is the point and C is the point, but here number 0, 1, 2, 3, 4, 5, 6, 7. This is the path and this is the kilometer path, 1 kilometer, 2 kilometer, 3 kilometer and 4 kilometer. Now let us consider you are at point A, your position is point A. Now this is the point A. Now you have reached point B by 4 kilometer way by riding a bicycle along the curved path. That means you riding this path by bicycle. That means this is a 4 kilometer path. Now we can say the distance between point A and point B is 4 kilometer. That means this is the distance, 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer. This is the point A, this is the point B. Now we can say this is the distance of 4 kilometer. Distance is a scalar quantity. This distance is a scalar quantity. So to express the distance between the points A and B, we need not mention any direction, because this is a scalar quantity, so we need not mention any direction. We determine the distance of the point B along this path with respect to the point A. Now if we desire, we can determine the displacement of point B with respect to point A by displacement. The position of point B with respect to point A is meant in the figure. This is the figure. The displacement is shown by a straight line from point A to point B with an arrowhead. That means this is A point, this is B point. This is our straight path and this is our displacement. This is our displacement. Displacement is a vector quantity. It has both magnitude and direction. The difference between the initial and final position is the displacement. The difference between the initial and final position is the displacement. Now the displacement from A to form B and the displacement from B to A are not equal. That means for this is A point, this is B point. Our displacement is this straight line path. Our displacement is this straight line path. So here this displacement A from point A to B and the displacement from B to A are not equal, because this is one is positive but another is negative. One is negative of other. In vector form we can write, if we consider AB is positive, then our next displacement BA equal to negative. This is, if we consider this is arrowhead, that means this is positive, AB is positive, but if we consider B to A, then we get this is negative. Then AB equal to minus BA. Distance or displacement both have the dimension of length. Distance or displacement both have dimension of length. This is displacement expressed as L. This is a vector quantity, and distance, this is expressed as L, but this is a scalar quantity. Now go to the next topic, speed and velocity. Roughly we know what is meant by velocity. The measurement of how fast a body is moving is called the velocity. I repeat, the measurement of how fast a body is moving is called the velocity. In physics, velocity has a definite meaning, and in addition to velocity, we use another quantity named speed. if we have understood the two terms distance and displacement properly, then we will be able to understand two terms speed and velocity very easily. Now, speed is the rate of change of the distance with respect to time. I repeat, speed is the rate of change of distance with respect to time. Therefore, if we have covered 100-meter distance in 20 seconds, your speed will be, then we know the formula S equal to Vt, that means we find V equal to S by T. Now we putting the value of S equal to 100-meter distance, this is the distance, this 100-meter distance, we put this value here, and this is the time, we put the time here, then we after calculating this we get 5 meter per second. That means here is a speed equal to 5 meter per second. The dimension of speed, third bracket V equal to LT minus 1. LT minus 1. This is important, my dear students. You should learn this dimension. And the dimension of displacement, distance, the dimension of speed, the dimension of velocity. Now, velocity is the rate of the displacement with respect to time. I repeat, you should underline this line. Velocity is the rate of change of displacement with respect to time. Therefore, if the change of your position along a certain direction is 50 meter in 20 seconds, then magnitude of your velocity will be, we can use this formula here. Now V equal to S by T, that means we put the value, we use this formula. Here is a V equal to velocity, S equal to distance, and T equal to time. We put the value of S equal to 50 meter and we put the value of T equal to here 20 seconds. Now after calculating this, we get the result 2.5 meter per second. Now as velocity is a vector quantity, we will have to fix its direction. The dimension of velocity V equal to LT minus 1. The dimension of velocity equal to LT minus 1. Our dimension is same, speed and velocity. Now go to the next math. We consider, this is one kind of formula already I have discussed, average speed equal to distance traveled by time. We can write shortly here S equal to Vt, that means V equal to S by T. Now we put the value of S and T. Here our S value is 4 kilometer and our time is 20 meter. Now putting this value in here, now 4 kilometer, we convert kilometer to meter, multiply by 1000, then we write 4000 meter by 20 minutes. 20 minutes we convert to minutes to second, then we multiply with 60 seconds, then we get 20 into 60 seconds. After calculating this, we get the result 3.33 meter per second. Now here is another math. Here is average velocity. Average velocity's formula equal to displacement by time. Displacement by time, we can calculate the same procedure, V equal to S by T. Now putting the value of S, our S value is 3 kilometer. Now we convert kilometer to meter by multiplying 1000, then we get 3 into 1000 meter, and by 20 minutes convert to seconds, then we multiply 20 into 60 seconds, then after calculating this we get the result 2.5 meter per second. My dear students, the whole thing you will read at your home. I hope you have understood today's topic. See you again in the next class. Till then, Allah Hafiz.